Let's look at 2.1, basics of functions and their graphs. So we are going to look at domain and range, function or not a function, representing an equation as a function, evaluating a function, graphing the vertical line test, um, obtain information about a function from its graph, identify domain and range from a graph, identify intercepts from a function's graph. So some important vocabulary is relation. Relation is a set of ordered pairs. So your ordered pairs are X and Y. It can be listed as a set where you have like this, X, Y, X, Y, X, Y. So because they have these brackets, that's a set. Discrete are listed as whole units only. Data is listed as ordered pairs or points on a graph that are not connected. So it would be similar to a scatter plot. So that is discrete. When we do domain and range of discrete, we do a list, which we'll talk about in a minute. Continuous includes fractions and decimals. It's what the word says, continuous. It continues on. It's connected. So data is listed as an equation with two variables or points on a graph that are connected, a line or a curve, something like that. So domain and range is a set of all the first components of an order pair. It's called the domain of a relationship. Range, set of second components, is called your range. So domain is all the x values, all possible x values. And range is all possible y values. Okay. So let's look at domain and range for a discrete relation. So this is a discrete relation. Domain is all the x values. So remember how we have x comma y. So all of our x values is our domain. We write it as a list, a set, 0, 1, 2, 3. And we usually want to write them in order from least to greatest for domain and range. And then range, I'm going to do my y values. 187, 212, 225, and 238. So that is from a list. And this is discrete. And so when we do discrete domain and range, we make a list. Domain and a range from a graph. Domain is you look for all the inputs on the x-axis. So we're going to do left to right on the graph. Because remember the x-axis, if you think back to the x-axis, the x-axis is going from left to right. So that's your domain. And then your range is your y values. That's your y-axis. So it's going to be low to high. Just like with discrete, we list in order from least to greatest. With continuous, we do the same thing, least to greatest. And we will write it as an inequality. So I'm going to show you what that looks like. So domain and range for discrete functions are written as all possible x values for domain and y values for range. Written, as an inequality, as inequalities. Sorry, a couple typos there. All right, so our domain is going to be left to right. So what we're looking for is how far left and how far right. So this is left. I'm going to write the coordinates for that, 2, 1. And then right is 6, 1. So for domain, we're only looking at the x's. So it's from 2 to 6. And we're going to write it as a compound inequality. We can also write it as an interval. Interval. Also. So it's not just inequalities. You can write it as an interval too. So it's going to go from x will be between, I'm going to leave space for my inequalities on both sides of the x. 2 and 6. So this is a closed circle. So when we do inequalities and we graph them on a number line, open circle is just less than, closed circle is less than, equal to. And this one is 6, and it's an open circle, so it's just less than. So what this means is x can go as low as 2 and including 2, and up to 6, but not including 6. So these are all the possible x values. There's no x value at 0, at -1, at -2, at -3. There's no x value at 7, 8, and so on. All the x values are between here. So then we'll do the range. So this was our left, by the way, and this is our right. I forgot to write the interval notation. So interval notation is going to be a bracket. We'll go with the or equal to. So it's going to be from 2 to 6, and it doesn't include 6, so there's a parentheses there. So see how it's written here, 2 to 6. So now let's do the range. Range is low to high. So the lowest is right here. And range is our y values. So look at your y values on there's 2 low points. 1. They're both 1. This one's included, this one's not. So it is going to be included. So it's the y values between 1 and, got to come up with our high point. How high does it go on the y-axis? And it goes to 5. If you wanted to, you could write the coordinates 4, 5, and you want to just use the y value, so it's 5. So it's from 1 to 5. It's included on this point, but not this point. That means that 1, the value of 1, is actually on all the y points, or some of the y points. There's 2. So it's a less than equal to. And then 5, see how it touches it? There's not an open circle there, so it's going to be less than equal to also. Okay, so let's look at something else. So this could also be written as the interval notation of 1 to 5. And since it's included, we are going to put brackets around both of them. Okay, so let's look at the next one. So domain is our x values, range is our y values. So we need to look at how far left and right for our domain, and then low to high for our range. So left to right. Oh, it's the same thing. It's the same problem. All right. So we've already done that one. Let's go on to the next one. This is a linear function. So here is our function, the blue line. So this one's going from left to right for the domain. So left would be -1, -2, -2, -1, 2, 3, 4, 5, 6, 7, 8, -8. We're just using the x value. And then right, that arrow means it's going to go on and on and on. It's not going to stop. So that means it's going to go right to infinity. If it was going to the left with an arrow, it'd be negative infinity is the left value. So this is saying it's going from -2 to infinity. This point is included, so it's less than equal to. This point goes on and on forever. You can never actually touch it, so it looks like that. So it's saying -2 is less than or equal to x is less than infinity. So if I cover that up, I can flip-flop these around, and its x is greater than or equal to -2. So see how the x value is at -2, and then it goes to positive infinity. So that means it's greater than or equal to that -2. The interval notation would be it starts at -2 and goes to infinity. This is a bracket because it's included. This is a parentheses because it's not going to actually touch infinity because you can't. Okay, and so then we have our range, low to high. So low, which is the same as left here. It's the y value, so -8, y, and then up. So see how this is going to continue to go up, 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 up. So high is going to go to infinity. We use a less than equal to on this one because it's a closed circle, and then just a less than here. We are going to cover this up. We want the y value first, just like we wanted the x value first. That's why we flipped it around. So I'm going to flip these around. Whenever I flip the number in the variable, I have to flip the symbol. So that's why it's like this. So this says y is greater than or equal to -8. So it's going to start at that -8, and it's going to go to infinity. So greater than or equal to -8 means -8, and then anything higher than that. So interval notation would be -8 because it's included to infinity. All right. Let's go to the next one to define domain range from a function from its graph. So domain is left to right. So they kind of put boxes around it, but we're still doing the same thing. We're doing left to right. So this point is at -2, 0. And this point is at 1, 3. And we use our x values for domain. So the x value is from -2 to 1. It's going to be included because we have closed circles here. So less than equal to, less than equal to. And the less than equal to are both going to be the bracket. So -2, 1 bracket. So all the x values on this function are between -2 and 1, including both of those numbers. The range is going to be low to high. So this is my lowest value, which it's the same point on this one. 0 to high. This is my high point. The highest it goes is 3. So in this case, the low is the same thing as left. The high was the same thing as right, but it's not always like that, to 3. And both closed circles, so less than equal to, less than equal to. And then our interval notation is going to be 0 to 3. And so if you look here, the difference between here is we have two boundaries here. Meaning it's going left, it's going right, and there's a stopping point at each one of these points. But this one only has one boundary. This is a boundary, and then it goes to infinity. So that's the difference. All right, let's look at this next one. Identify the domain and range again. So domain is x value. So we have -2, 2 is our left value, because remember domain is left, and this other point is our right. 1, -1. So we're going to go with our x values. So it's -2, +1. Then we have an open circle, so it's just going to be less than. Closed circle is going to be less than equal to. And we always go least to greatest, and that's why we use the less than equal to. Always go least to greatest. In this case, with domain, we go left to right. With range, we go low to high. So we would write this as -2, 1. This is a parentheses because it's just less than. This is a bracket because it's or equal to. Okay, so let's look at the next one. I mean, not the next one, but the range. So low to high. So this one's my low. This one's my high. See how it can be mixed around? Low and left are not always the same. So y value. So it's -1 because that's the y value of our low to our high 2. And the low one's the one that's closed, so it's going to be like that. Y is open, so it's going to be like that. So -1 is less than or equal to y is less than 2. So when we put it in our interval notation, it's going to be written like this. The bracket's going to go on the -1 because it has less than or equal to. 2 is our parentheses. So that is domain and range. Let's look at definition of a function. A function is a correspondence from a first set called the domain and the second set called the range, such that each element in the domain corresponds to exactly one element in the range. So 2 things that you can do to check to see if it's a function. X values do not repeat. So you could look at just the x's. We don't care if the y values repeat. We're looking at only the x's if they repeat. And then we have the vertical line test, or you might have heard it as a pencil test. We're going to see that in one of the next slides. It's checking to see, does the function go through the vertical lines more than once? So like this is not a function. And the reason is because look at this vertical line. See how it goes through twice? If I have this, if I do vertical lines down it, it only goes through once. This is a function. Not a function, function. All right, so the first question says determine whether a relation is a function. So just look at the x's. X's do not repeat, so yes. X's do not repeat. The y's repeated, but we don't care about that when we're determining if it's a function or not. Vertical line test. This is a function because if you draw multiple vertical lines, everywhere it touches the relationship, it's only once per vertical line. So this is a function. This one is not a function because look, it crosses twice on that vertical line. The circle is not a function. Okay, functions as equations. If an equation is solved for y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. So if we just have y equals 3x plus 2, that is a function, and it's actually a linear function. If we have x equals half y minus 6, well, to determine if it's a function or not, you would solve for y. So to solve for y, I would need to get this 1/2 y by itself by moving this minus 6, so plus 6. And I get x plus 6 equals half y. To get rid of something times a half, I would actually multiply by 2 over 1, which is called your reciprocal, which really means I'm just multiplying by 2. So this, where I distribute, would be 2x plus 12 equals y, or y equals 2x plus 12. So this, too, is a function. Because you have y equals just one value of x. We don't have that y is equal to 2 values of x. So here's an example. This is actually the circle equation. X squared plus y squared equals 1. So the solution, we would need to solve for y, which is what they did. Draw a line down. We're going to subtract x squared. So then we get y squared equals 1 over 1 minus x squared. take the square root of both sides and see how it has this? That means that y equals square root of 1 minus x squared, and y equals negative 1 minus x squared. You can't have a y value equal 2 x's. Yeah. No, the other way. So the plus minus shows for certain values of x, there are 2 values of y. So for one value of x, there are 2 values of y. For this reason, the equation does not define y as a function of x. Okay, function notation. The special notation f of x, f parentheses x, read f of x or f at x represents the value of the function at a number x. So anytime you see f of x, that's the same as saying y equals. All this x is saying is this is our input for x. Will come some output for y. So on this example, we have f of x equals x squared minus 2x plus 7. Evaluate f of negative 5. So that means that instead of saying f of x, I'm saying f of negative 5. So that means when x equals negative 5, y equals what? So what we are going to do is plug in that value, plug in negative 5 for x. Everywhere you see an x, you're going to plug in a negative 5. So it's shown here. So we have x squared minus 2x plus 7. Plug in a negative 5. Plug in a negative 5. And then simplify. So you plug it in. Make sure whenever you substitute in, you use parentheses around it. So plug in parentheses, negative 5 for x. We can also use our calculator. So let me show you how we would do that. So we would plug in, we'd go to y equals, sorry, that's really hard to see, it's dark. There we go. X squared minus 2x plus 7. And if I want to know when x is negative 5, what is y, then I can go to second table and go to negative 5. So on a table of values, I would look for negative 5 and see what y is. In this case, it was 42. So there are 2 different ways of solving it. You're going to plug in a number for x. You're going to use your table of values. Okay. Let's look at evaluating a function. More examples. So this is f of 5. So f of 5 for 8x minus 8. That means I'm going to do 8 times 5 minus 8. Do it in your head or do it in your calculator. But 8 times 5 is 40. 40 minus 8 is 32. And so the way you would check your work is you go back to y equals and you would put that in. 8x minus 8. Go to your table and I want to plug in 5. 32. Okay. So this was for A. I'm going to get a different color for B. B, in this case, it has f of x plus 1. So that means everywhere I see an x, I'm going to plug in an x plus 1. So it's 8, parentheses, x plus 1 minus 8. So whenever we have that, we need to simplify it. So we're not going to get a one answer solution, and we're not going to be able to use the calculator either. So we're going to have to substitute and solve. So 8x plus 8 minus 8. Well, 8 minus 8 is 0, so it just equals 8x. Let's look at B. We already did B. C. F of negative x. So that means I'm going to plug in a negative x for every time I see x. So 8 times a negative x minus 8. So 8 times a negative x is just negative 8x minus 8. And we're done. This is our solution. We can't do anything else because we've simplified, but we can't get rid of the x. We can't combine it with anything. So that's as simplified as we get. So let's look at the next one. This one is an x squared problem, which is quadratic. So a f of negative 8. So we are going to substitute in a negative 8 for x squared. So we can simplify that by hand. We can use our calculator. We could substitute into the calculator. So I'm going to do it by hand. Negative 8 squared is negative 8 times negative 8, which is 64. 6 times a negative 8, negative 48, plus 4. That would be 12 plus 4 more, 16 plus 4 is 20. Let's see how good my math is. Mental math. Let's see. So we'll go to y equals, clear that out. X squared plus 6x plus 4. And then go to your table. Second graph for the table. We're going to go to negative 8. 820. Okay, good. We could have also done this, parentheses, negative 8 squared plus 6 times a negative 8 plus 4 to get it as well. So either way works. All right, let's go to B. It says f of x plus 6. So that means that everywhere I see an x, I'm going to plug in x plus 6. So it's x plus 6 squared plus 6, x plus 6 plus 4. So this is going to require us a little bit more work. So remember the box. If you need to do that with me. We're multiplying because this really means x plus 6 times x plus 6. All right. So I would get x squared, 6x, 6x, and 36. 6x and 6x make the 12x. So this is going to be x squared plus 12x plus 36. All right, so we've gotten that one. We do need to distribute here. So that'd be plus 6x plus 6 and 6 is 36 plus 4. Now we look and see if we can combine like terms to simplify it all the way. X squared, can't do anything there. But then we have a 12x and a 6x, which makes that 18x. Then we have 36, 36, and 4. So 36 and 4 make 40. 40 plus 36 makes 76. And it says to simplify. So that's as far as we can go. All right, let's look at the last one. It says we want to put in a negative x for x. So f of negative x gives us negative x squared plus 6 times a negative x plus 4. Negative x squared means negative x times a negative x, which is going to give us a positive x. So that negative is going to go away. 6 times a negative x is negative 6x plus 4. That's all we can do. That is our solution. All right, let's look at the next slide. The graph of a function is a graph of its ordered pairs. So you plot them, x, y. The x-intercept is these will be important for you to find. X-intercept is point where y is 0, also called root 0 solution. So we have x, comma 0. you'll be asked sometimes, what's the solution? What's the root? What's the zero? You can also be called or it can also be just called X-intercept. And it's the point where the x-axis is 0. So let's say this is our line. This is our x-intercept. Okay. Then for our y-intercept, if we have a graph, let's say it's like this. This is our y-axis, so this is our y-intercept. So it's 0 for x, a number for y. If they go through the origin, 0, 0, that would be an x and y-intercept. They could be the same. Let's look at types of functions. So we have linear. Anytime it's just y equals x, y equals 3x plus 2. It is a line on the graph. If it extends both direction, your domain and range are all real numbers, or negative infinity to positive infinity. So let's say it goes like that. Your domain will be negative infinity to positive infinity. So will your range, because it has no boundaries. And so this is your linear parent function. It goes through the origin. It is a straight line. So important is line. Quadratic is going to be x squared. It's going to be a parabola. So whenever it's graphed, it looks something like this. Mine was not the best. But anyway, it's going to be a parabola. And this is going to have boundaries because it's going to start here and extend forever. The cubic is, so linear has no turns. Quadratic has one turn. Cubic is like y equals x cubed. It's going to have two turns. So let's say it's like this. So it turned and then it turned again. Absolute value is going to look like a V. It's not going to be in the bottom unless there's a negative x squared. So it's going to look like this. Square root, like this. It's going to look like this. And then polynomial could have more than one term. So I'll give you an example. Let me see what. Let's say I have x to the 6th plus x to the 5th minus x to the 4th plus 2x to the 3rd. Like, it just has all kinds of twists and turns. And it has more than just the cubic. So cubic goes up to the 3rd power. Polynomial has to a bigger power. So I just kind of came up with one with my highest power being 6. So let's graph it and see what it looks like. See if we can even see it. Okay, so it has all kinds of twists and turns. So it's just going to have more than one. So it could be like that. That's an example. More than 2 turns. So this has turn, 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 turn. So we're going to talk more about polynomials. We're going to spend a lot of time on that. All right, so let's look at a graph. So it says graph the functions f of x equals 2x and g of x equals 2x minus 3 in the same coordinate system. Select integers x starting with -2 and ending with 2. How's the graph related? The graph of g related to f. So if we look, here is the two graphs. So When I say f of x equals 2x, x is -2. That means we're going to plug in a number for x. So in this case, it's -2. So 2 times -2 is -4. 2 times a -1 is a -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. So we can graph it. We can also put it in here. Y equals 2x. And we can look at the grid starting with -2. So we can use our calculator for all this too. So when we graph it, -2, -4, -1, -2, 0, 0, so it goes through the origin. 1, 2, and 2, 4. So we'll connect those with a line. I have something to connect them with. I don't have a ruler. All right, so then the next one is 2x minus 3. So I can go in, and in y2, I can put that 2x minus 3. Then I can look at the table, and this will be my table for the, so we're starting with -2. For the second one, the g of x. So I'm going to plug in a -2. So 2 times a -2 minus 3. 2 times a -2 is -4, minus 3 is a -7. -5, 0. It's -3. And 1 is -1. So I can't fit that one on my graph. I can fit that one though. -1, -5, 0, -3, 1, -1. So something like that. So see how they're parallel? The reason they're parallel is because they have the exact same slope. The difference between them is the graph of G is shifted down 3 units. Okay, so see how it was at the origin? Shifted down 3 units, exact same slope. Your slope is the number in front of x. All right, let's look at the next one. Graph the following functions, f and g. Describe how it's related. So x, y. So I can plug in -2, -1, 0, 1, and 2. And this will be for my f of x. So I would plug in a -2. I'm going to go ahead and just put it in here. So this would be -x squared. This one would be -x squared plus 4. I do want to just do the first one though. So starting with -2, I get -4, -1, 0, -1, and -4. So -2, -4, -1, -1, 0, 0, 1, -1, 2, -4. So see how this has the x squared? These are quadratic. So it's going to look like this. So then the other one is the same quadratic, but it's plus 4. So this is, oh, it's not f of x, it's g of x. So -2, -1, 0, 1, and 2. So whenever I look at my table, let's see, it will be starting with -2, it's 0, 3, 4, 3, 0. Okay, so then when we graph it, I have -2, 0, negative 1, 3, 0, 4, 1, 3, and 2, 0. It's also quadratic because of the x squared. So see how they're the exact same shape? Just the g of x is shifted up 4 units. Okay, let's look at analyzing the graph of a function. So it says use the graph to find f of 5. F of 5 is 400. So that means that the x value, when x equals 5, y equals question mark. So you look at f equals 5. It's right here. So see how this is 400. It's 5, 400. X is 5. F of x, or f of 5, is 400. So then to get for what value of x, so we want to know x, when x equals question mark, y equals 100. So we're going to look at 100. So it kind of looks like right there, right? Because halfway in between, that's 100. So this case, we're doing y is 100. What is x? X is 9. So this is at 9, 100. So f of 9 equals 100, which gave us a 0.9, 100. Okay, find the following. F of 0. So that means when x is 0, what is y? It's 1. This is 0, 1. X is 0, y is 1. F of negative 6. So that means when x is negative 6, right here, what is y? Negative 6, negative 1. Negative 1. F of 7. Let's go to 7. Looks like it's right here. It's at 0. X is 7. Y is 0. So we can look at a graph to find the function values too. All right, last thing is intercepts. The x-intercept, you're going to look at for the point at which the graph crosses the x-axis. The y-intercept, look at the point where the graph crosses the y-axis. A function, so remember what a function is, x's can't repeat, can have more than one x-intercept, but at most one y-intercept. If it's a function, it can only have one y-intercept. So the x-intercepts are, in this case, negative 3, negative 1, and 2. So we could write those as coordinates, negative 3, 0, negative 1, 0, and 2, 0. The y-intercept is where it crosses the y-axis. It's right here. It is negative 6. That would be at 0, negative 6. Okay, so that is 2.1 for you. Hope you have a great rest of your day.